Hello, I'm going to share with you our presentation at the Poultry Science Association Annual Meeting 2020. The title of the presentation was Effect of the Inclusion of Enzyme-Treated Soy Protein, HPIV start, in starter diets of two different amino acid density feeding programs on performance of broiler chickens. As you know, soybean meal has several anti-nutritional factors that may damage poultry performance. The main anti-nutritional factors in soybean meal are trypsin inhibitors, soybean oligosaccharides, and the antigen beta-conglycinin. You can see here on this slide, on the left side, we see that the content of trypsin inhibitors in the final compound feed has a negative effect on the growth of birds. You see here that the higher the content of trypsin inhibitors in the diet, the lower the body weight of chickens. On the right side, we see likewise the effect of stachyose, one of the main indigestible oligosaccharides in soybean meal. Again, the higher the content of stachyose, as you can see here down with different colors, the lower the body weight of birds. Based on this knowledge, we ran a trial with the objective of evaluating the live performance of HPIV stat, an enzymatic treated soy protein with very low content of anti-nutritional factors, in the startup period from 0 to 14 days at two different amino acid densities, 88 and 100% of the genetic recommendations, compared to control groups from 0 to 49 days. We ran this trial at the Poultry Research Center of the University of Georgia in the United States. We used 1,104 COP 500 male chickens distributed in 48 flow pens, 48 replicates with 23 birds per replicate. You can see here the experimental design. It was a factorial design. We had two main effects. The first main effect was the amino acid density. We had two treatments, treatment 1 and treatment 2, with 100% amino acid density, whereas treatment 3 and treatment 4 had 88% amino acid density. The second main effect of this factorial design was the inclusion of HPIV start in the starter diet. So we had treatment 1 and treatment 3 without any IV start, the starter diet. We had treatment 2 and treatment 4 with 5% IV start in the starter diet. We had 12 replicates per treatment and 23 birds per replicate. You can see here the diet composition of treatment 1 on the left side and treatment 2 on the right side, both with 100% amino acid density. You see here that treatment 1 had 33% soybean meal, whereas treatment 2 had 27.6% soybean meal only, plus 5% enzyme soy protein, enzyme-treated soy protein, which is HPIV stat. So, as you will see later, we reduced the content of anti-nutritional factors in P2 by replacing part of soybean meal by HPIV stat. Likewise, treatment 3 on the left side and treatment 4 on the right side, both with 88% amino acid density. Treatment 3 had 27% soybean meal and treatment 4 had 21% soybean meal plus 5% IV start. You can see here the nutrient composition of the experimental diets. On the left side, you have treatment 1 and treatment 2 with 100% amino acid density. They had similar amino acid profile and they were isocaloric and isoproteic. On the right side, you have treatment 3 and treatment 4, both with 88% amino acid density. They were isocaloric and isoproteic as well, and they were supposed to have the same amino acid profile. What about the study timetable? So we assess the weight of birds and feed consumption on days 0, 14, 28, 35, 42, and 49. And data was analyzed with a factorial analysis, and in case of significant interactions between the two main effects, we compared means by using a test. Let's have a look at the results, and we start with the anti-nutritional factor content in the starter diets. As you can see here on the top, we have the 100% amino acid density diets, and we see that by replacing part of soybean meal by 5% IV starch, we reduce trypsin inhibitors, soy oligosaccharides, and beta-conglycinin by 10, 16, and 17% respectively. The same for the treatments with 88% amino acid density. By replacing part of soybean meal in the diet by 5% IV starch, we reduce trypsin inhibitors by 12%, oligosaccharides by 20%, and beta-conglycinin by 22%. These are normal reductions we usually find in the market when we include 5% HP IV starch in a starter diet. Of course, it will depend on the content of these anti-nutritional factors in the soybean meal you are using, which has a huge variability. However, we would be usually within this range, between 15 and 20% approximately. Let's move on to the performance results, and we start with the starter period from 0 to 14 days. And you see here that we had a significant interaction between the two main effects, amino acid density and inclusion of HP IV starch in the starter diet. That's why we need to look at the means of each treatment by treatment. And as you can see here, we didn't see any significant difference in body weight gain and FCR between the two diets with 100% amino acid density, with IV starch treatment 2 or without IV starch, enzymatically treated soy protein during this period. However, if we look at the diets with 88% amino acid density, we do see differences here, and we see that birds that were fed with IV starch supplemented diets resulted in lower body weight gain, 389 grams versus 441 grams, and higher FCR, 1.33 versus 1.34. We did not expect these differences. Actually, we have run several trials, many trials, in different markets, in different locations, different countries, under different conditions, and we do not see differences at this age, usually. So that was very surprising for us, and we tried to figure out what happened here. We found out that there was a difference between this diet, T4 and T3, in the content of lysine. So T4 was about 10% lower in lysine than T3. So something must have happened during the manufacturing process, we don't know, which did not happen in the manufacturing process of T1 and T2, because actually these two diets did show similar content of lysine and the rest of amino acids. However, if we move on to the next period from 14 to 28 days, we see that there was no interaction in body weight gain, and therefore we can see the main effects. We see that there was no effect due to IV starch inclusion, but there was a significant effect due to amino acid density. The higher the amino acid density, the higher the body weight gain between 14 and 28 days. But we did see an interaction, a significant interaction in FCR. And here, that's why we look at the results at the means of each treatment. And again, we see here that there was no difference between T1 and T2. They had the same FCR, but we saw a significant difference again between T3 and T4. T3 without IV starch and 88% amino acid density, and T4 with IV starch and 88% amino acid density. But this time it happened the other way around. So IV starch feed supplemented birds showed a significant lower FCR than the control birds with 88% amino acid density, but we thought IV stat T3. And we understand these results as a kind of compensation of what happened in the previous trial. So IV stat birds here compensated their poor performance in the previous trial. So if we look at the next period, 28 to 35 days, we see that there was no interaction between main effects, and therefore we can compare here the main effects. We didn't see any significant effect in this period with regard to body weight gain, and we saw a significant difference in FCR, mortality adjusted FCR, due to density. So the higher the amino acid density, the lower the FCR. However, we didn't see any significant effect due to the inclusion of enzyme-treated soy protein, so HP-IV stat, during this period in FCR. However, I must say here that we saw that those birds fed IV stat supplemented diets during the previous period show a numerically lower FCR than the control birds, 1.78 for IV stat versus 1.82 for the control birds. And as you can see in the next experimental period, this difference, this improvement, numerical improvement due to IV stat became significant between days 35 and 42. And you can see here that we had a significant improvement for both body weight gain and mortality adjusted FCR due to IV stat. So birds fed IV stat supplemented diets grew 680 grams, whereas birds fed control diets grew 624 grams only. And the same for FCR. FCR for IV stat supplemented birds was 1.92, whereas IV stat in the control, FCR in the control groups was 1.99. In the last period of this trial, in the last experimental period, we saw again a significant effect of IV stat on body weight gain. So IV stat supplemented birds grew 459 grams during that week, whereas control birds without HP-IV stat in the starter diet grew 406 grams only. There was no difference, no significant difference during this week, the last week of experimental trial. However, what happened during the overall experimental period here, and you can see on this table that there was no significant interaction between the two main effects, amino acid density and the inclusion of IV stat in the starter diet. Which means, in other words, that regardless of the amino acid density in the diet, IV stat does perform and does bring a positive effect, as you will see here. Let's start with first with the effect of amino acid density, and we can see here that amino acid density during the whole period had a significant effect on FCR, both mortality adjusted FCR and body weight adjusted FCR, adjusted for 3,400 grams. So, however, amino acid density did not have any significant effect on body weight gain during the overall experimental period from 0 to 49 days. Let's look at the effect of the inclusion of this enzyme-treated soy protein, HP-IV stat, during the starter period. So we see that the inclusion during the starter period did have an effect in the overall period. And we saw that both mortality adjusted and body weight adjusted FCR were improved by the inclusion of IV stat in the starter period. So mortality adjusted FCR was improved by 2 points, whereas body weight adjusted FCR was improved by 5 points, significantly improved. With regard to body weight gain, we saw a trend here, and we saw that birds that had been fed HP-IV stat supplemented starter diets tended to grow more than the control birds. So the growth here was 3,430 grams for the starter, for the Hamlet HP-IV stat supplemented birds, and was 3,300 grams for the control birds. So we can conclude then that the inclusion of HP-IV stat from Hamlet Protein in broiler starter diets at 5% reduced soy anti-nutritional factors by 10 to 17% and 12 to 22% in 100% and 88% amino acid density diets, respectively. The positive effect of the reduction of anti-nutritional factors in the starter diet was observed, however, from day 35 onward. That's why we call it a carry-over effect. We feed birds with this clean protein, IV stat, without anti-nutritional factors during the starter period, so we reduce the content of anti-nutritional factors in the whole diet in the starter period, and we observe the benefits of this reduction later on in terms of performance from day 35 onwards. No interaction was observed between the inclusion of IV stat in the starter diets and amino acid density on performance of broiler chickens at the 3 commercially significant market ages, 35, 42, and 49 days. Again, here, in other words, that means that regardless of the amino acid density in your diet, IV stat does contribute improving performance of our birds. So it doesn't matter the content of the level of amino acids you have, you will see a positive effect of HP-IV stat. Replacing part of the soybean meal in starter diets then will improve mortality and body weight adjusted FCR by 2 and 5 points respectively on day 49, replacing soybean meal by 5% of HP-IV stat. Furthermore, it has been observed that high amino acid density in diets for broiler chickens during the entire breeding period also improve performance of broiler chickens and particularly FCR. Thank you very much.